Okay, so let's talk about something that's totally changing how software gets built and at a wild speed. It's called vibe coding. This is the new frontier, right? Building entire applications pretty much just with AI. And while it's super fast and honestly really exciting, there's some pretty serious dangers hiding just beneath the surface. So let's dive in.
1.5 million. That is a huge number. But what is it? This isn't just some abstract statistic. This is the actual number of API tokens, and you can think of those as digital keys to really sensitive services, that were exposed out in the open by just a single application. An application built, you guessed it, entirely with AI. And believe me, this is just the tip of the iceberg.
And this code just hits it home. This isn't a what-if scenario. The Maltbook platform was a real live application that leaked not only those 1.5 million API keys, but also 35,000 user emails and their private messages. And why? It came down to a hard-coded API key. A secret password was literally just written into the public code, and most importantly, some crucial security rules that were completely turned off. It was a total disaster, and it happened for one reason: relying on AI without any human safety checks. So this brings us right to the heart of the problem, what we're calling the vibe coding trap. What is this new method that's so tempting for developers? And, why does it create this perfect storm for security nightmares?
Here's the long and short of it. Vibe coding is all about moving fast. It's about talking with an AI, asking it to spin up whole applications, and doing it at a pace that was basically science fiction just a few years ago. But the trap is right there in the speed. All that acceleration often means developers are just blowing past the slow, methodical, and absolutely critical safety checks that are supposed to prevent these kinds of disasters. And when you skip those safety checks, you leave one particular door just wide open. In fact, after researchers scanned over 1,400 different AI-built apps, they found one single vulnerability that popped up way more than any other. It is, by a long shot, the biggest unlocked door in AI-generated code. And here it is. The number one vulnerability is missing row-level security. Seriously, almost every major data breach you read about that involves one of these vibe-coded apps, it comes right back to this one single critical mistake. It's the digital equivalent of building a brand new bank, but completely forgetting to put locks on any of the vaults. So what even is row-level security, or RLS? Well, the best way to think about it is like a bouncer for your database. It's a set of rules that looks at every single request and asks, hey, are you actually allowed to see this specific piece of information? It's the make or break policy that ensures you can only see your own data and nobody else's. And this comparison just shows it perfectly. Look on the left. With RLS turned on, the user has a key and it only unlocks their data. Simple. Everything else is locked down tight. But now look over at the right. With RLS disabled, which, by the way, is often the default setting that AI models just forget to change, that lock is just gone. Now, a single user can get to the data of every single other user in the whole database. The vault door is wide open for anyone to walk through. Okay, so this brings up a massive question. Why are AI models so bad at this? Why do they keep forgetting to implement a basic fundamental security rule like RLS? Well, the answer is actually baked into the way these AIs learn in the first place. This is the key right here. A large language model doesn't think about security. It doesn't reason about what's safe and what isn't. It's a pattern-matching machine, plain and simple. It's been trained on billions of lines of code from all over the internet, and it just spits back the patterns it has seen the most. And that includes tons of examples of insecure code, half-finished tutorials, and just really bad habits. And the data doesn't lie. Just look at this table. It's comparing vulnerabilities in AI code versus human code. And in every single critical area, the AI-generated code is way more flawed. It's nearly twice as likely to have network security problems, and it's much, much worse at handling errors or file operations safely. The AI isn't just making tiny mistakes. It's failing consistently where it matters most. This quote really gets to the deeper issue. See, the AI doesn't just rate bad code, it teaches bad practices. When a developer gets a suggestion from an AI that has a hard-coded secret in it, again, that's like a password just sitting there in plain text, they start to think that's the normal way to do things. The AI's bad habits quickly become the developer's bad habits, and these dangerous patterns just start to spread. So, if we can't fully trust the AI to build things securely, that responsibility has to fall back on us, the humans. We have to build a defense system around it, something we can call a human firewall that catches everything the AI misses.
And the solution really starts with a big shift in how we think. We have to stop just accepting AI code blindly. From now on, we have to treat it like any random piece of code you download from the internet. I mean, you wouldn't just grab a program from a shady website and run it without scanning it first, right? The same discipline has to apply here. The new rule is simple. Assume AI code is insecure by default. So what can you do? Right now, here are 3 simple actionable rules. 1. Use a secrets manager. This keeps your API keys and passwords totally separate from your code. 2. Never, ever paste sensitive info into a public chatbot window. That data can be saved and used for training. And 3. Automate the process of catching mistakes. Use tools called pre-commit hooks. Think of them like automated security guards that scan your code for secrets before it can ever be saved.
And beyond those individual habits, a strong human firewall needs good team processes. This means every single chunk of AI-generated code gets reviewed by a human, especially if it's touching sensitive data. It means you've got to have automated scanning tools built right into your workflow, catching errors early and often. And it means using version control, so you always have a safe checkpoint you can roll back to. It's all about building layers of defense.
But here's a really interesting twist in the story. AI isn't just the source of the problem. It's also, kind of ironically, becoming a really powerful part of the solution.
Yeah, the whole narrative is changing. This isn't just a simple story of insecure AI versus smart humans. The new front line in cybersecurity is actually becoming a battle of AI versus AI. You have AIs that are building the applications, and then other AIs that are designed specifically to defend them.
And you can see how this works in the real world. We now have AI agents that give developers security feedback in real time as they're writing code. We have AIs that can generate those complex row-level security rules from just a simple English sentence. They can scan entire systems on their own looking for weaknesses, and they can even dream up new kinds of attacks that a human might never even think of. We're literally fighting fire with fire.
And that leaves us with one last really critical question. We know for a fact that AI has made building things faster than we ever thought possible. So the challenge now is, can we use that same incredible power to make defending those things even faster? The race is on, and honestly, the security of all our data really depends on who wins.